Cool. Again, as a reminder, all of my sessions are recorded, so you don't have to quickly jot everything down. Just take a seat, take your calculator out, plug in the values, calculate them with me, and just pay attention. So for number 2, it says graph the following functions. You have y is equal to negative x times x minus 3 times x plus 4. Okay, so we're just going to do a recap with multiplicity and degree, and also the sign of your leading coefficient. So those are the three things you have to remember if you're graphing functions, and specifically they're polynomial functions, right? So this is a polynomial function. So first, let's identify three things as I mentioned. So if you're looking at this negative sign right here, that indicates that you have a negative leading coefficient, right? And you're probably wondering right now, what does the leading coefficient and its sign has to do with drawing or graphing the function, right? So if it's a negative leading coefficient, so we're going to have that right here. So leading coefficient. So if it's a negative leading coefficient, that means when you're graphing your function. So for example, if you're looking at a linear function, which is y is equal to x, say for example, versus y is equal to negative x. So we know that if you're graphing y is equal to x versus y is equal to negative x, if it's a linear function, that means your line is passing quadrant 3, right? Because this is quadrant 1, 2, 3, 4. Versus something like y is equal to negative x, which is quadrant 2 and quadrant 4. Does that make sense? So the negative leading coefficient or the positive leading coefficient would determine whether your function is passing quadrant 1 and 3, if it's let's say y is equal to x, versus quadrant 2 and 4 when it's a negative leading coefficient. Same thing really applies for example, y is equal to x cubed, right? Which is what we know is an odd function, right? So we have something like this. So we know that it's quadrant 3 and quadrant 1 when it's positive, and if it's negative x cubed, we know that this is quadrant 2 and quadrant 4. And guess what? It's similar to y is equal to x squared, right? So let's just scroll down just to see and compare them. So y is equal to x squared. This is going to be on quadrant 2 and quadrant 1, right? And if you have y is equal to negative x squared, you're going to have that on quadrant 3 and quadrant 4. Does that make sense? So it matters where you're going to graph that. Okay, so I can erase this now. So that's for the sign of the leading coefficient. So let's move on to multiplicity versus degree. So you've probably heard what multiplicity is, and also zeros, right? Zeros and multiplicity are related to one another. So for example, you're looking at x, right? So first of all, you have x minus 3, and you have x plus 4, right? So your zeros are going to be 0, right? Because x is a 0. And you have positive 3 and negative 4. So maybe we can just group this based on the smallest versus the largest. So we have negative 4 to begin with because it's x plus 4 is equal to 0. Therefore, you're going to get negative 4, right? And then you have 0, comma 3, right? 0 for your x minus 3 is equal to 3, right? So in that case, you're going to see that the multiplicity of x plus 4 is going to be 1, right? So what is multiplicity? So multiplicity is when you're looking at different terms, and then you call this sort of like an exponent. So if you look at x plus 4, your exponent right here is actually 1, right? So the multiplicity of negative 4 is actually 1. Multiplicity of x minus 3 is also 1, right? So let me erase this so you can see everything. So this is 1, right? This is multiplicity of 1, and this is also multiplicity of 1 because all of your exponents are actually 1. Does that make sense? Okay, so multiplicity is 1, 1, and 1, right? However, if you're looking at the degree of your function, that means the degree is your summation of all your multiplicities, right, it's going to be 3, right? Because 1 plus 1 is 3, right? So the degree of your function is 3. Okay, so why does the degree matter? Well, the degree matters because at least you know which quadrant it passes through, right? Because if you're thinking about an odd function versus an even function, right? This is what I tell my students to really remember during the test. So if you're looking at, let's say, a negative leading coefficient, if it's an even function, so say for example, you have negative x squared, right? You would have to, so this is the one that we talked about earlier, you would have to look at quadrant 3 and quadrant 4, right? So you know where your function is going to start and where it's going to finish. So it's going to start at quadrant 3 and then you're going to finish at quadrant 4. So that's the position of where you're going to draw. However, if you're looking at y is equal to negative x cubed, you know that it's not at quadrant 3 and quadrant 4 because it's actually at quadrant 2 and quadrant 4. Does that make sense? So when you draw this graph, you know that if it's degree 3, therefore it's an odd function, right? And if it's an odd function, you're supposed to expect that this is what the quadrants, or this is how your graph is sort of going to look like. So these are what you call like templates that I like to tell my students to remember during the test. So you have an idea of where you're going to start drawing the graph, because otherwise it's just going to be overwhelming. Okay, so now that we have that, we're going to have a number line, and then you're going to graph all of your, sorry, not graph all of your zeros, but plot them, right? So this is -4, 0, and 3. Okay, so we know that this is all of your zeros, and then first of all, because it's a negative leading coefficient, it's an odd function, you're supposed to start on top of your x-axis, right? This is your x-axis. And then because you know that the multiplicity of x plus 4 is 1, that means you're going to cross, right? Okay, so here's the thing. If you have an odd exponent or odd multiplicity, you cross. Okay, maybe we can just write that here. So odd multiplicity, that means anytime you have an odd number and it's multiplicity, so say for example you're looking at 1, 3, 5, 7, right? All of your odd numbers, you're going to cross your x-axis. And if it's an even multiplicity, you're going to bounce, right? So you're only touching, you're not crossing. Okay, so let me just abbreviate that. So cross, and then you're going to bounce, right? So in that case, you're going to cross. You're starting from quadrant 2 because you know it's a leading coefficient of a negative sign. So you're crossing this, right? Again, at 0, because its multiplicity is odd, you're going to cross this again, right? And then you're going to cross another one for 3, right? Okay, there we go. So this is how your function is supposed to look like. So you're just crossing, right? But, okay, moving on to part B, right? If your, let's say your exponent or multiplicity in this case is odd, but it's greater than 1, you have what you call an inflection point. So instead of just crossing, so say for example, let's plot this together. So we now have positive leading coefficient. Okay, I'm just gonna abbreviate coefficient as co-f, but that's coefficient. And your zeros are essentially -3, right? X plus 3 and +2, right? And then your degree now is going to be 5, right? And the reason why it's 5 because it's 2 plus 3, right? So degree is the sum of your multiplicity. In that case, because it's an odd function and it's a leading coefficient, you have a template which is y is equal to x cubed, right? And as a result, you're going to have, or you're going to expect that your function is going to start from quadrant 3, right? And then you're going to have somewhere, something on quadrant 1, right? Because it's positive leading coefficient and it's an odd degree. Okay, so we have that written down. Now, how do you draw your graph, right? So when you're drawing your graph, you're going to have -3 and 2, right? Again, we mentioned because it's starting at quadrant 3, that means you're supposed to have your function starting from the bottom, right? So you're starting here and drawing up. So because at -3, you see that it's 3, right? It's an odd multiplicity, however, it's greater than 1. That means you're going to have what you call an inflection point. So an inflection point is also crossing, right? But it's a little bit flatter because you have a change in, there we go. Let me just, okay, there we go. So this is flatter as opposed to just crossing because you have a change from concave to convex. Basically, that's what it is. So it's like this right here. So you have a change in your concave to convex, and then this is a little bit flatter, right? So that's what happens at -3. But if you have, let's say, at 2, right? If you're looking at x minus 2 and this is 2, you're just going to bounce, right? And how do you know it's not going this way, right? Going down? Well, if your function is odd, that means you're going to finish at quadrant 1. So that means it has to be on top of your x-axis, right? Or above your x-axis. So you're going to bounce here. Okay, so see that bounce? So it only touches your x is equal to 2 and it doesn't cross that because